Bismillah ar-Rahman ar-Rahim, in the name of God, the most gracious, the most merciful. Welcome to Lady Khadija radiallahu anha online college live lesson A-level maths, pure maths. It's year 2 of the edXL Pearson syllabus. We're looking at the chapter of trigonometric identities and equations. In the last lesson, we looked at using the cos A plus B formula to be able to rewrite something that looked a little bit long, looked a little bit complicated, and just write it in a short form. So now we're going to build on that and go ahead and solve the equation. So let's take a look at the example we were doing. Bismillah ar-Rahman ar-Rahim, in the name of God, the most gracious, the most merciful. So yesterday we had an expression which was 2 cos theta plus 5 sine theta, and we wanted to express that, we wanted to write that in the form, a shorter form, which was just made up of cos. So the form that we wanted to write it in was r cos theta plus alpha. Sorry, theta minus alpha. So in yesterday's lesson we did that. We figured out how to rewrite the long version of the cos A minus B formula and compare that, and we ended up with the answer that we can write this whole expression in a much shorter form, which is square root of 29, that was the r, multiplied by cos theta minus 68.2 degrees. So let me just say that again. Root 29 times cos theta minus 68.2 degrees. So everything in the top line can be rewritten as the bottom line. So now in the next part today, what we want to do is to be able to solve the equation 2 cos theta plus 5 sine theta is equal to 3 for theta between 0 and 360. This would typically be a part B question because you want to use your work in part A to be able to make this very, very easy. So all you do here is you say, look, this 2 cos theta plus 5 sine theta, that was exactly the same thing that I was working on in part A. And I managed to say that this whole thing in part A, it could be rewritten as just something with cos in it. So you take advantage of that and you say, look, if the equation now I'm trying to solve is that same thing, then I can put that away and I can bring in my new expression. And that will be much, much easier to solve. Because firstly, it doesn't have cos and sine, it's only got cos. And secondly, there's nothing really complicated about it. All we're going to do, let's make a little bit of space. We'll take the root 29 over to the other side, or whatever number happens to be there. So that's a fraction now. And all I've got is cos, so I can just inverse cos. So if I inverse cos 3 over root 29, I'll get 56.1 degrees. So I can say that I can say that the theta minus 68.2, once I inverse cos, then I get the answer of 56.1. I can drop the brackets now, and then I can add. Before you want to just not so quickly at this stage here, you have to slow down a little bit and say, look, when I inverse cos 3 over root 29, I do get one answer on my calculator, but there's other answers as well. So you have to use the fact that the cosine graph It repeats every 360 degrees. It's also symmetrical about 0. So there is one other answer, which is minus 56.1 degrees. So let's squeeze that in as well. Not just one answer, but many other answers. One of them is minus 56.1 degrees. The other answers we can ignore because they go above the 360 limit for this question. Okay, now we can rearrange. So now here we've got minus theta minus 68.2 degrees. So I'll add 68.2 degrees to every angle to get rid of that minus 68.2. So I'll end up with just theta on the left is equal to, and once I've added the 68.2, the minus 56.1 becomes 12.1. That's your first solution. And then your second solution, the 56.1, once I add 68.2 to that, I get 124.3. And that's how you solve the equation. Join me for more in the next lesson. Assalamu alaikum wa rahmatullah. Peace be with you and the mercy and blessings of God.